Let's put this on the main screen. We are live. So let's change the title to playing and exploring SML. Okay. Okay, so the plan for today is for us to start learning SML because this project is going to be written in SML and we don't have Magenta, so that means we're going to have to learn things by ourselves.
Yeah, Magento is not available today.
Yeah, and so the first thing that I did was to we don't know how to program in SML. I think it's going to be fairly easy given that I know F sharp, but I don't know the quirks. Marinho also doesn't know the quirks, I think. So I just wrote SML examples in Google. So let's see what we can
Yeah,
find here.
I actually don't know very much about the statically typed side of functional programming because most of my experience is with Lisps.
Um, I would say that this is not a big of a deal. It's just a matter of where you're doing your constraints. Because in Lisp you're basically using predicates all the time. In here you're gonna write a type signature and that's all. Everything else is just a matter of syntax most of the time. The thing that I think we're gonna struggle the most is to use modules and how to identify that we need them. I have a fairly good guess, which is the same problem that we had in Racket Tower back in the day about wanting to have a type class. And Magenta told me that if you had that same problem in SML, you would make a module to solve it. So I made a blog post about that. You can find that in my blog later, Marinho. But I described fairly easy the problem. The solution in Haskell, Rust, and apparently SML or ML languages, it would be 100% straightforward. Um
I think I remember reading that. Wasn't that the one where you went into the details of the modern OOP solution to this problem?
yeah,
And
yeah.
then I entered the project and I was like, bro, what are you doing?
uh, yeah, but to be fair, you didn't solve the problem. You changed the architecture. So you suggested to get rid of the modern OOP, which doesn't address the problem. The problem is still there, and I think it's going to be always there. Which is I wrote that. But Magetta told me that the solution to that problem here would be a module. So that's something to keep in mind. So that's what we're going to be doing today. Today is just an exploration, very chill, learning from scratch programming language that I never used it, Marinho never used it. So we have, again, SML examples, just Google, literally just Google. I'm not even judging them, I'm just opening them. So the first one that appears, I believe this is the first one, or this is the first one, is some XML expression. So it is an expression-based language, which is expected. And it is an infix language, so that's also good to know. So it seems to contain operators. Um,
Yeah, the if expression is identical to Haskell.
yes, the if is exactly the same thing. Whatever this person is, so I don't know how to pronounce your name. I'm sorry, but he's talking about the type inference, which is fairly okay. So it has type inference, which is expected. Um, okay, so this is the
I
concat
mean,
that triggers me.
I mean, this is the OG type inference language, so that's to be expected, I guess.
Yeah, and this is the minus. Jeez.
Oh, I think they went with that because they didn't want to overload the minus sign to have different meanings depending on the number of arguments.
I see. It has precedence.
Yeah, I already don't like that.
Well, this is one of the main things to me that which why I like S expressions, regardless if it's in a Lisp or not, because then I don't have to care about this uh, and stuff like that.
Yeah,
Um,
life is too short to memorize precedence rules of obscure languages.
it's not about being obscure or not at all. Like I don't like this in Haskell as well. It's fine,
I
but I don't. I
I mean
prefer S
most
expressions.
I mean most programming languages are obscure if you consider them in the context of the entire human population of the planet as opposed to just the programmer population.
Yeah, but nobody would ever understand it like that. When you say obscure in the tech industry, you're basically saying that whatever is not JavaScript and Python is obscure. Slash
Well,
s, I guess.
uh, aside from the fact that we don't mention the P words here, um,
The P word.
yeah, I don't like Python. That's not a secret, and I will keep reminding people in the future about this.
Sure.
Um,
What the heck is going on
but
here then?
yeah,
Is this a valid name?
that's apparently it is. How interesting. How lispy.
Yeah. So this apparently is functioning as a let. I wonder there's no lets in this language then. It's everything is a vowel or a fun. It's immutable by default. Thank you very much, sir. No promotion of types. Thank you so much, sir. Okay, but this is a thing. So does it have shadowing?
Well, probably.
Mm, this statement gives me the feeling that it doesn't. Okay, so these are functions. I want to know if the syntax for typing them is also the same as F sharp. Just as a declaration, we give interactive or be part of a program. Yeah. Um,
And this is the main difference from Haskell.
what?
The arguments are always evaluated before the function is applied.
Oh, sure. Um, yeah, that's true. So the arguments are always evaluated before the function is applied. Okay. So in this case, this will be evaluated before the evaluation of this, which I think it's okay. Type inference, it does have tuples, which is like Objective C doesn't have them, so good to know.
Zeek does,
Yeah, Zig does as well. The
and it's
syntax for
lower level
typing,
than Objective-C.
uh, it is lower level than well, both can go to C at any point. So I don't know how to say it to put that correctly. The syntax
Yeah,
is the
I
same
don't.
to describe the tuples.
That's kind of weird. I'm not gonna
Yeah,
lie.
no, that's weird, but you're gonna get used to it. I learned this in F sharp. Easy,
Functions
just
with
use
many
tuples.
arguments. Yeah, this is different from Haskell, right? In Haskell, you would say use currying, but here they actually suggest to use tuples.
That's actually a good question. So it doesn't have curring by default?
It probably does, but it's just not the way people do things.
No, but how? No, but that's the thing. In F sharp, you would not say that this is a tuple. You would say that this is a function that takes two things. By saying that this is a tuple, this gives me the feeling that this is not currying. The way that he said it. Maybe this is just to make a joke, just because the syntax is similar.
No, the syntax is actually exactly the same. It's not just similar.
Yeah. Similar in the sense that this is a function. This is not a function. But this piece is similar to this. Um,
It's literally just destructuring the tuple in the function definition.
yeah, bro. There's no. Okay, let's go continue. Maybe another resource will show us that it does have curry. So it has recursion. This is the evaluation process. What will this function compute? Uh, I guess it will hang.
It will loop forever.
And the answer to this question, why triangle is not circular, is because it has a base case. A list is either an empty list or a pair of elements in a list. Makes sense. Every language that supports ADTs implement them like that, I think.
And this is another thing that's different from Haskell. You use a colon to denote the type and a double colon for cons. In Haskell, it's the other way around.
Oh yeah, but this is always also the case in F sharp and OCaml, I think. The list above has could also be have written, yes, this. But yeah, but this is useful to know in the beginning. And that's it. Sum of elements. This is just a recursion doing a fold. Okay, so there's nothing more. What if I hack it? No, I can't hack it. Okay.
Mm. You got outsmarted.
Come on. Come on, bro. Like, isn't there like an index that I can search? Oh, there is. There is. Um, okay, cool. So it's this guy. So let's see what we can find in here. Uh, lecture plan. Okay, curring is lesson 2. Um, programs presented in the lecture. Um, okay, so it's just saying HT9 whatever whatever 2009. Slides and suggestions. Okay. For projector SML PDF.
Hurrying.
Okay.
Chapter 9.
Okay, okay. So these are the lectures. That's interesting. So let's go to tuples and records. Okay, so this is actually a little bit better because this has more stuff, it seems. We already saw this. Okay, so it has booleans. Okay, that's good to know. What is size though? Oh, this is the size of the string. Okay. Basic types. So it has what are strings like lists of chars? That would be interesting to know here. Uh, integers. So the precedence is here. They have yeah most of what you would expect. They have mod by default, which is cool. Real numbers, it
No,
gains two
no
things.
div mods though.
What?
No div mods though.
Div mod. What do you mean?
An operator that returns both the quotient and the remainder.
Ah, okay, okay. Yeah, but that would be the type of stuff that we could make ourselves using the other ones.
Actually,
That's
that's backwards because it's more efficient to provide div mod as a primitive
no, no,
than
no.
to
Yeah,
provide
I
div and mods
agree. I
separately.
agree. We could. That's the best way, performance-wise and reusability-wise. But I'm talking only like if we need that, we can make that function ourselves. Mm.
The OCaml community is proud of you.
Well, in Okemo it's a different story because this language that has it's lacking a bunch of stuff and it's abandoned in the vacuum of existence. Okemo is still Okemo. There are products in the world using Okemo. I'm more fine by doing things by hand in this language than in Okemo. Um, okay, so the strings. It says that as a string is a character sequencing. What does it mean to say that it's a sequence, friend? That doesn't help me at all. Um, that's kind of interesting. So they have these operators for strings. What is the semantics of those, man? What are the semantics?
It's written right below the table.
Use of the lexicographic order according to the ASCII code. That's unexpected to have these out of the box, but okay. Um,
Why?
ooh, it is because I don't remember any prelude that I can recall in which you can do this with strings out of the box.
Well, I'm pretty sure you can in Haskell.
Um, I have a hard time saying that, remembering that, because I never had to do that, but I can try that out later. So truth values, true and false. Attention, true with a capital P is not a value. So it has uppercase and lowercase it is distinguishing between uppercase and lowercase, such as like Haskell. What is this?
It's
And
the
also.
AND operator.
But is that the name? And also?
Yes, apparently.
That's funny. Oh yeah, it is. Hilarious. Um, oh, it is lazy. It has optimizations. That's interesting. Um, yeah, so we have examples here. Type conventions. So this is to because you don't have promotion, so you need to do these things usually by hand.
By the
Uh,
way, go back to the table where it shows the numeric operations real quick. I actually have a curiosity.
Numerical table.
Um, uh, Below, you went back too much.
Is this the
Next
one?
page. Uh, I think it's the next one actually. Div infix operators associated to the left. Operands are always all evaluated. Go to the next page. As usual, except the unary operator is a tilde, examples of values, and then it doesn't say which definition it uses for division.
No, it doesn't. Maybe we can find that somewhere. So this is just for conversion of numbers. Also, same as Haskell. This is a new one though. So to convert a char to a string, you just call str. Okay. Evaluations of expressions. We already saw that before. We saw this before as
Conditionals.
we saw this before as well. Yeah, this is not a statement for control flow. It's an expression. Um, Value declarations. Yeah, the same thing here. Bizarre, no? uh,
It has type string.
the identifier it always has the result of the last unidentified expression.
I think
Um,
that's for interactive usage.
yeah, no, this is for interactive. This is for the REPL. Okay, so this is how you do a declaration to make a binding. So there are no lets. We have vols instead. In ML, there are only variables in the mathematical sense, no assignments. It's just labels. It's not a memory. It's not literally like being converted to a memory region. This is a completely different non-assignment stuff. Evaluation declaration from left to right. Simultaneous evaluations of the right hand sides. Function declarations. And so this is how you do it. This is exactly how you do in F sharp in OCaml, I believe. So the types they go alongside the values, which is very annoying because if you I want to have like put the type signature when I'm doing the modeling of the first design, there's a bunch of noise of things that I don't care, such as labels and stuff like that. But that's okay. Uh, okay, so then we have these things, beta reductions. The argument is always evaluated before calling the function. Yeah, that is different than Haskell for sure. Possibility of simultaneous declarations. That is interesting actually. So as far as I can tell, you need to do this to do mutual recursion.
Oh, that's where the end keywords went.
Yeah, good catch. Yeah, I think this is I believe this is why you need this to do mutual recursion. Blah blah blah. SML does type inference, which can be great, can also not be great. It depends on exactly how the inference works. Uh-huh. If a type cannot be inferred from the context, then the default is that the overload operator refers to the function on integers. You can give clues, like tips. Uh, what is this?
That's um, that's the explicit type annotation.
Uh, yeah, but it is mixing that with the times. Oh, okay, so this is actually considered an operator. That is interesting. I don't remember Haskell. In Haskell, we have like the double column having a being called an operator. So it competes with what you would normally call an operator in here.
Well, it is. I'm pretty sure it is in Haskell as well.
I never saw people giving that a name or calling it an operator. Um, Just like integers, functions are objects, yes, because it's a function first class citizens language. So you should be able to have higher order functions then. Okay.
One is syntactic sugar, which is how it should be.
Anonymous functions. So fn is the keyword of choice for
Not
anonymous functions,
backslash.
not backslash. But I think this is always also the case for F sharp and OCaml. Okay, so this is how you can. What? What is these things? Is this for the course that they were doing? There's no fucking way you can write this and it's okay in the language. There's no way. I think this is for a convention for the course. Because this is a material of whatever university.
Probably.
There's no because this is like dependent typing shit.
Yeah,
Okay.
this is not Idris.
Yeah. Okay, so tuples and records. I want to see the records. So group n values of possibly different types. Blind closing them in parentheses. We know that. There are no one tuples in ML. I don't think Haskell has them as well. At least not in the prelude. There's probably a package that adds them. Um, I want to see how to make records though. Tuples of tuples. Cartesian product. That's why. Yeah, I remember that from F sharp as well. This is unit. Examples. Okay, records. Nice. Is this nominal typing? Is that the correct term?
I don't think that's the correct term.
Mm. Why not?
Nominal typing actually has to do with type definitions, not uh, whatever this would be. How can I explain this? The distinction between nominal and structural typing is that when you define a type, uh, if it's nominal, then you may have the same definition with two different names and they would be considered two different types, even though structurally they are the same.
Yeah, no,
And
no.
structural typing is,
I know, I know.
yeah,
I
and
think I understand that. But I asked because then you're basically saying that records and you cannot make like a record type then in here.
well, you can probably. It's just that if you have two definitions where their structure is the same, and if the type system is structural, which I think it probably is, I think at least I recall OCaml using structural types, so ML probably does as well. But
Yeah, we have in our language. We have anonymous records. We call that the term that we used in silverware is that you can have anonymous records. And I think this is what this is not. Yeah, I think this is similar because as you said, you're not defining a type. This seems to be a value. Then you're using vol. But I wonder if they have. You can define like a record type.
well, you can look at the next line.
Which line?
You have the example, right, where you say val it equals course FP year two, and then you see the colon that denotes the type of the expression. So the next line has the type.
Yeah, no, but this is the type of this anonymous thing.
Yeah,
So if you have another thing, course FP year two, and check their equality, they would be equal. Even if they are different, they have different. One is record A and the other one is record B or whatever. Like in terms of the type of them, if they were nominal,
Well,
if you could
we
give them a
actually,
name.
to be fair, we haven't seen a type definition example yet.
Yeah, that's also true. Yeah, so this is the value record. Okay, and this is anonymous, structural, I guess. Um, so then you can have this, and that works. Um, what is happening here?
Where?
Oh, you are extracting the field A from this record. The type is integer. Makes sense. Then you say that this is equal to this, and it says that this is a boolean. This
It
is
is
not equals to
true.
this.
Apparently,
Go on.
yeah, it's showing that the order doesn't matter in our records.
Yeah, yeah. Because if it did, these would be tuples, not records. Um, mm, that is interesting. You see what's going on here? I see what's going on. I think. I would never guess
Yeah,
this would work.
the indexing is one base. That's terrible.
Well, maybe if you put 0 and 1, it would work as well. I have no idea. Yeah, this would this is confusing that you can because if you put a particular key of for the field name, then you can use it as an index for checking with the normal tuple. That's kind of weird. In ML, a function has a unique argument and a unique result. hmm Multiple result functions. Here, returning a tuple. Div check. Yeah, this is unit for side effects. Curring. Let's freaking go. Let A be an object of type A and be an object of type B. Yep. Attention. F of a tuple is different than FAB. Yes. A function ML object, just like an integer. The result of a function can thus be a function. Okay, so this points to having curring by default. Every function on a Cartesian product can be curried. What is this?
Wow, it's a reference to actual curry, which is the
Yes,
name
I
of.
know, but that
Uh,
was like. Okay, do we have examples? Oh yeah. Oh no, we don't actually. Um.
we actually do
Oh
fun
no,
log base
log base
x.
x. Yes. Wait. So then, to separate the arguments, you can use space for them. So when we saw that before, that those were tuples. Yes. Okay, good to know.
Yeah.
Those were tuples indeed. Yeah, it's gonna explain that the non-curried version and the curried version are produce the same value. You can actually make them. Yeah, it's irrelevant for the case of having the value. Why can log2 bits not be declared with fun rather than vol? Log2 bits.
Lower. It's on the next page.
Mm, no, that's. Oh yeah, actually it is. Wait, log2 bis. Oh, bis. That is very interesting because log2 bits, log2 It is. I think it's because it is explicitly asking for the thing, and then this one it's not. You see, this is like the output of this is a function that then takes a new thing, which is different than what you're doing before. So that's why this can't be a fun. This needs to be a val. Did you get it?
Yeah.
I think that's the reason. Pattern matching. So it has pattern matching, which is something that I missed during Racket Tower. Um,
I mean, you could have always just imported the match macro. It's
sure.
just using it for structs in Racket is not usually a good idea because then you are depending on the actual positions of the fields of the structs, which is not very nice.
Um, yeah. So, but the left-hand side of a value declaration is called a pattern. It must contain at least one identifier. Wait a moment. Oh no, you do have X in here. Uncaught exception bind. What do you mean? I'm confused. Why this worked and this one didn't?
Because the right hand side of X is true, it fails to match that pattern.
Oh, oh yeah, that's true. This is a value that he's defining before. So we are pattern matching this thing. I got completely confused. My bad. So identify can occur at most once in a pattern. Okay. So we do have case, and this is the syntax. So this is the real switch case. Like real means meaning C. Um, so oh, this is also important. So this is the at in Haskell. In I think Camel F sharp here as well is S, which can make phenomenal jokes because of that.
Um,
Did you get it? This is this fine for you?
yeah, no, this is fine. It's analysis.
Yeah. General form. So this is the syntax. If none of the patterns is applicable during evaluation, then we have an exception. The first one is the first applicable one is used, which is also the case in Haskell. Can if then else be expressed via case of? Uh, it depends. It depends on the predicate.
The answer is yes.
Yeah. Um, so a plus b, we a lot. A lot. That was
Really a
funny.
lot. No, but
uh,
it can because you can just say, um, here, let me write it out. So if A and A here is like just a placeholder, it can be an arbitrary expression.
no, no, it can be. I thought there could be predicates that you would have to like mess up with exhaustiveness, but that's not the case. Yeah, it totally can.
No, no, you can just do something like this.
Oh, this is pattern matching on a function. Very cool. So this is like Haskell's then, right?
Yeah, in Haskell you can do the same thing, except it's kind of uh, hidden behind a layer of syntactic sugar because you actually say the function name multiple times. Or
Oh, in
actually, to
Haskell
be
as well.
more precise, you split it up into separate declarations. Here it's just one, except it's a very large compound declaration.
Yeah. Uh, you can do the same with fn, which I don't think it's something that you can do in Haskell. I don't think you can do anonymous functions pattern matching like this. Maybe I am not aware of it, and maybe that's a thing, but I never seen it before. Uh, oh no, I lied. There is a way, I think, with the slash case. That's a language extension though. Yeah, that's what that's what you did.
Well, here he actually used a function and, well, yeah, but you can do the same thing using a case.
Local declarations without a local declaration. With a local declaration. Oh, okay. So you create. Oh, so you use a let? Yes. So this is where the let is. So you use vol for stuff. But that is interesting. I don't remember ever have seen vol in F sharp and OCaml. So you do need the let, but you still use the vol. I would never guess that.
Well, I think that's because you can say let fun as well.
Mm-hmm. Let fun. That's it. Which by the way, that's very cool. This reminds me of the defines in Racket. That you can have like a local function that doesn't need to be in a let fun. You can have like this loosely, whatever order with this piece of syntax. You can define operators. Declaration of an infix operator. It is possible to declare new infix operators. How do I say that though?
Infix to XOR.
Oh, okay. So it is by adding this thing. Okay, that's good to know. Not everything is more readable by being prefixed. Um, so that's very interesting. But okay, can I go back and forth between them though? Oh, I can, but I need a special keyword. Ah, I rather use the parentheses like Haskell though. Why special keyword? Can I do this by demand? Can I say infix and then use the infixed in whatever function, then use known fix, and from that point onwards I can use the prefixed again? Can I like sections of
Congrat-
the code?
Congratulations, you are thinking imperatively.
Not really. I'm thinking how F sharp works. How I think OCaml also works like that. Like the order does matter because that's basically what I'm
Which
saying.
is
The order
imperative.
matters of the blocks.
You're basically saying, okay, compiler, from this point forwards, treat this operator as an infix operator. That's totally imperative. You're literally setting a flag in the compiler.
Uh, if you want to look at like that, that's fine. But for me, it's more like because in Haskell doesn't matter the order of your stuff, right? If you can put a definition before the use case of it, after the use case of it, and that's completely and utterly fine. But there are languages that obligate you to follow an order, like C, for instance, but F sharp as well. I think Clojure as well, right?
Closure as well, yeah.
So that's kind of like where I'm going with this. Does the order matter? Because if the order matters, if we're gonna allow the order to matter, why not allow this then? To just be
Apparently it does. So
Okay, but that's good to know that you can do this. Recursive functions. So this is also a case that you need some sort of. Okay, so there are two versions of it. There is a fun fact and a val rec fact. But the val has an fn within it, so this is a fun. Um, oh, that's it. So we should actually run this. Okay, am I ready?
I guess I am.
We do have the gist file, so let's actually I don't remember anymore. Just run. No, this is gonna take a while. Okay, so we're gonna see which one works, which one doesn't. Side effects. Like ML has functions with side effects, um, but it's just unit. So just like OCaml, just like F sharp, nothing too crazy. Sequential composition. So you do that with the parentheses apparently.
Parentheses and
Unknown
semicolons.
character. So there is crap here. Uh, I think I'm gonna have to write this by myself because there are some hidden characters in the PDF. This is an error in fact. That's weird. The indentation forces me to go to here. So I think it doesn't like it like that. Actually, it doesn't like it at all.
Hit backspace.
No, I was hitting. Yeah, no, but okay. So now it is now fine. That's a weird way to do your thing. Then one and else.
You
Um,
forgot the zero there.
I forgot the zero there. And minus one. So this is probably it has some hidden characters or whatever the crap. Oh, there you go. So value or constructor. Oh, okay, it's error. Okay, so let's say print. Types mismatch between then part and else part. Ah, minus one. That's not how you do that, right? It's this is how you do that. No, interesting. Wait, but I said just run, right? I did ask to run it.
Yeah.
Hello from Canteen. What? Am I going nuts? Uh, I'm not calling hello anymore. Why is it doing it like that though? Like, why did it is saying hello? Okay, just build this madness to me. Oh, I guess I need to do it like that. Uh, type error. So, oh, we need to convert this to to a string. So int to string SML. How to convert integer? I don't really care. Okay, so this is a thing. In short, no. SML is designed to use. No, I don't want to know how to do it. Have we seen how to do this before?
Well, it was in
Oh,
the
real
question
to
that you
string. Okay, so there's probably an int to string.
lowercase 2.
Okay,
There you go.
so apparently it is just a matter of syntax then. If you want to use the val, you need to put the rec on it. But if you use a fun, that's fine. Apparently that is the thing. Okay, so good to know. Very good to know. So to do the sequencing is just parentheses with semicolons. This is also the case in OCaml, and I don't remember an F sharp, the F sharp. The use function, loading and evaluation of the content of a file. This allows declaration of functions in a file. Okay. Exception declarations. Okay, so the first thing that they do is to go straight up into that, which is kind of interesting. So exception is just that. And then you have a fun that is using arrays. How can I better define my exceptions though? I would be very interested to know that.
Exception, error div.
Yeah, no, but I want to do some special behavior, like a custom message. How do I do that?
There's probably a try catch or something to that effect.
Uh, Wait a moment. You see this? It's saying error, safe div division by 0. And then you have your custom error message, but we don't have error, right? I tried using error and it didn't work at all here. So maybe we need to import something because that's polyml and this is like probably just the standard, you know?
Maybe.
Um, Using anonymous functions to directly verify the base. Yeah, so he has error. Okay, and this is just the pitch, right? So this is a speech about why you should care. We already care, so it's fine. Um,
It's fine.
so I want to know. Okay, so PDF programming with recursion, forms of recursion. Yeah, we definitely know this already. This is just pattern matching, correctness. Yeah, this question is a problem, my friend. This question can be a problem in very, very different domains. Proof by induction, yeah, you also does this in class. Uh, Proof by induction, blah blah blah. This is 2009. This is this is so reminiscent of when I did with Edu, the FP course. He did many, not many of these, but a few of these, but in Haskell instead of SML. Yeah, this operator is a complicated one. I've seen this in the math course before. Specification. Okay, so is there more like learning SML things? Type declarations. We definitely want to take a look on that one. Let's take a look on lists first. 17 pages. Fine. Wait. Okay, so a list of functions. Nothing too crazy. Um, oh, so this is the place where he explains polymorphic types. So you use type variables like this. Basic operations. We have isEmpty, head, tail. We don't know if they are total functions. Whatever. What will they do if they fail? That's a good one. Uh, this is the cons operator. This should not work, and it doesn't, as expected, right?
Uh, yeah, it shouldn't.
Yeah. Constructors and pattern matching. Ooh, the symbol double column is not an ML, it's a value constructor. Only constructors can be used in patterns. Another value constructor for lists is the brackets. Uh, okay, it's explaining the double column. Okay, so this is how you pattern match with it, and it's fine because if it's a constructor, it's fine. Um, this is also equivalent to that. Comparison between lists and tuples, constructed form versus aggregated form. Okay, so this is concat. Weird.
Yep. And it's a terrible operator. Don't use it if your representation of sequences is a linked list.
Yeah. Um, Polymorphism. So that's the first thing that we're gonna do. Okay, so it's not total. Uh, yeah, but this is a polymorphic function. This is a polymorphic function. This is also a polymorphic function. The type of error. The type of its result is the some type variable, say alpha. So it must be possible to use error in any situation. The type of its result is the some type variable, say alpha. Okay, that's really interesting. Uh, the member function is polymorphic. It can be used with objects where alpha, yeah, so you need to provide a type first. Like the type can be seen as an argument, and then it's going to figure this shit out. Uh, it cannot be used with objects where alpha is a function because the equality test between two functions is a problem, right? If you are not using some sort of like trick. I think we saw that in the book, right? In the book club, that we actually have representations of functions because it's plain code, so we could do equality on them. Uh, but like,
Yeah, yeah. If the body of the function is transparent, that is, you can look at its implementation and like actually read the code as data, then you can do equality, that's fine. But then also you have the problem of implementation details of your compiler leaking into the semantics of your program potentially if you're not
oh yeah,
careful.
that can be very, very, very bad. So these equality types are denoted by variables of the form this. So this is probably like in Haskell we would say that is a type that has implemented the equal type class, and in here you use this notation in ML to denote them apparently, which is fine. Okay, so this is how so the fact that this has equality is just because an extra quote or tick,
Yep.
whatever the heck they call it. Um, So this is the type of it. You receive a thing and a list of things of the same type, and it returns a boolean. Then we have more operational lists. I don't know why. Okay, so reverse length prod. Oh, so this is just a product from to. Um oh, this is slicing. Sure. Then we can do non-recursive versions of factorial selections. So this is take. This is drop. This is last. This is indexing. Polynomials. Uh, polynomials. This is in reverse. That's kind of weird.
Well, that's because of how you index the list.
What do you mean?
The zeroth element is corresponds to the the
Oh, I
coefficients of
see,
the
I
zeroth
see. Yeah,
power.
no, that makes sense. I was just saying it's weird because I was expecting 25103 and it's exactly the opposite. But it makes sense. It's because of the indexing, yes. Um, Definition of poly. So this is how you define a type. At least a type alias. Um, Poly is another way of naming. Yeah, so seems to be a type alias because it's saying it's a way of naming.
Yep.
So poly, this can be used interchangeably. So this is definitely a type alias. Operations on polynomials. I don't think that's going to be. Yeah, and it's the end. Okay, so this is lecture of the lists. Type declarations. That's what I think I'm going to be more interested in. Revisiting polynomials. Cool. Okay, so this is how you do a sum type. So you have something called data type months, and then you use the pipe, and that's cool. And then you have a function weekend. That's fine, right?
Yeah, it is.
Uh, this is a convention. So you can make constant identifiers non-starting, not starting with the capital letter, uppercase. Hmm. You cannot share the same tag. No, that would be a problem. That makes sense. The impossibility of defining subtypes in ML, such as an integer interval. Yeah, that makes sense. Because I think this would be like dependent typing again.
Actually, no, it isn't. There is a paper about that specifically, um, and introduces subtyping in ML by defining an algebra of types first, and then deriving the type system rules from that. Um, uh, let's see if I can find the paper. Uh,
Oh, I see. Okay, so it is different than depend. It is sort of similar but different because this is only talking in terms of types. Dependent typing is doing like checking in the set of possible values, not possible types or type constants. I think that's the name that we are using here. So it is different, yes. It is different. Okay, my bad then. Uh, but this really seems like a dependent typing when he says 1 to 12 because numbers are not in the type definition. But this is subtyping. Um, the bool and unit, they are not primitives in ML. Makes sense. We have order. Constructed types. Okay, so this is how you make the tag with the value being holded. You see? This is how you do it. Are you there?
name of string. Yeah.
Yeah. So you need a name for the tag, and that just works. That just works. Okay. And you can probably combine them with the pipe. So like name, whatever,
I
value
just linked a
constructors.
paper about subtyping.
Paper about subtyping. Ah, very interesting. Okay, I'm gonna take a look. Here. So these are value constructors. Uh, Wait, if expression e reduces to normal form n of type int, then age e reduces to age n, which is of type age. Yep, that makes sense. Yep, these are also value constructors without arguments. Yeah, and you can use them in patterns. So then you can do pattern matchings with things like this. Typical types with several constructors. Yeah, so this is what I'm talking about. So for instance, in Racket Tower, we would have like a table here, and a procedure here, and a trigger, and a view, or whatever. And then you could have your stuff. You could have your stuff.
Yeah. The difference being that you define the type separately and then you just make a predicate that's an OR over the predicates of the separate types. And that's your new type with alternatives, uh, your sum type, if you will. It's actually
Uh,
more properly a union type because it's commutative, but you get the idea.
but that's the thing. In Racket Tower, I think we dropped the relationship between the entities, right? Because when we are using OOP, modern OOP, this was done via an entity superclass. And then the table and the procedure, they had a relationship between them because they were both entities. At the final version of the code, I think we have nothing that tells whoever that table and procedure have a relationship. And in here, they have also.
Yeah.
Um, okay, functions, blah, blah, blah. Extracting the values in a let. Normal stuff, normal stuff. So then we have more pattern matching. Wait, the union of types cannot be simulated. What do you mean, brother? When you say, what do you mean by union of types? Do you mean like integer, real, double, float? Is that what you mean? I think that's what he means. Recursive types. Yeah, pretty classic. With once you have ADTs, mutually recursive data types are declared together with an end and a with type. Now, more fun stuff. So, what if you want to have a type variable in there? You can. You just do this, and that works. It is really possible to redefine the list type. First, you need to write a non-fix. Okay. If you want to experiment with your own, you can use cons and new, the classic binary trees. This is the option, the same as in OCaml and F#. And now we can model some errors with it. Exceptions revisited finally. So okay, so you can put arguments in these things. I see. So that means that you can pattern match. Oh yeah, this is the try catch, right?
Handle.
Well, this is at least the catch, I think.
I mean, if you think about it, try catch is really just a single binary operator where you try to evaluate the expression on the left, and if it fails, you call the handler on the right with the exception that you got.
Yep. But okay, so you can pattern match on them like this, which is fine. Um, pretty interesting. Application expression evaluation. Oh, this is a calculator. Amazing. Okay, so this is how you do a calculator in 2 pages, basically. This is the code. You can extract this out to a separate function to make this like a lot better. And if you add an option to this, because you're doing division by zero checking, if you don't have functors and applicatives, it's going to be more extensive. Um,
You shouldn't use the term functor in the context of ML because
yeah, yeah,
in the
yeah, yeah,
context
yeah.
of
I
ML,
should be careful with that. That's true.
it means a different thing. Yeah.
Yeah, it means a totally different thing. Tail call recursion. Do you want to see how he explains tail call? Oh, it doesn't have a PDF though, so probably it's just like a
Notes.
live explanation. Abstract data types. We don't need sorting. Higher order functions. We don't have a PDF. Lambda calculus. Modules. I think we can finish with this today. So let's see. Why abstract data types? Useful to make a data type abstract when the implementation of the data type is complex. There are many ways to implement the data type. You want to keep the data type separate from the rest of the code. It represents a natural abstraction. Often a good way to split the program into parts that can be understood individually. Yeah, I would love having a class that starts with this question. This is so freaking philosophical, and I don't think people understand this properly. But this in a class would be amazing. This is probably a draft of an answer. Uh, I think some students will have their mind blown by the answer of this question. This is what I mean when I say that philosophy and computer science, they have, and math for that matter, they have a lot of intersection because they all talk about this. Um, so correctly parameterized texts determines whether a text is correctly parameterized. What do you mean, brother? Correctly
If the
parameterized.
parentheses match, I guess.
Oh, okay. It's balanced. That's what he meant. Okay. Uh, okay. These are some examples. Okay, so now he's going to talk about the procedure, an algorithm that you can do to check for that. Um, sure. More description on how to solve that. Necessity of an abstract data type for stacks. Oh, so he's going to solve this by using a stack. That's how I would also solve this.
Uh, that's not how I would, at least
Really?
not how I would
How
think of it
ironic.
naturally. Yeah, because here's the thing. You already have a stack. Normally, you use it to keep track of where you are in a tree of nested function calls. So why don't you just use the call stack for that? Like that's totally a thing.
Ooh, I think I see what you mean, but that's a bit convoluted though. That seems like shoving. You want to be the most performance balancing solving solution ever. So then you are exploiting the
Yeah.
data structure that is already there, and it will be there for that matter, whatever you do.
Yep.
Yeah, that feels like shoving bits, like optimizing to the T. Probably very unreadable in terms of somebody reading afterwards, but I see what you mean.
Um,
Abstract data type for stacks. So you receive a type first.
actually, actually, it's probably not that unreadable. It wouldn't be too different from trying to write out back grammar for this. The problem is that you actually need back some kind of backtracking mechanism for this to work.
Yeah, I see. Okay, so what he's calling an abstract data type is what he already discussed in the previous lecture about like things that receive a type is an argument. And this is the implementation of that apparently. And also is so weird. Is that a thing in PolyML? Is that how they call it? Yeah. Well, I don't know actually because this is just Emacs. So maybe we're gonna discover that the hard way. Realization of the stack abstract data type. Okay. Okay. Yeah. You can model the stack using a list, fine, and then you're gonna have to define some an API, right? So push, pop, top, or peek, right? Uh, empty stack
Drawbacks.
is empty
Look at the
stack.
drawbacks.
Where?
It's in the same page. It's just the text after the
Oh,
definitions.
this realization does not force the usage of the stack type. The operations can also be used with objects of type alpha list, which is true, right? So this is just a type alias. It is possible to access elements of the stack without using the operation specified above, which means that you are leaking. You have a backdoor, right? And the backdoor it should be closed. Nobody should ever do that. Be allowed to do that.
Yep. This is
Uh,
probably where they introduce modules then.
for encapsulation,
Encapsulation, yes.
encapsulation, sorry. Version 2, definition of an, oh, so these are proposals. So the version 1 is just using a type alias. Version 2 is to make a full-blown new type, which has a constructor, uh, which is also a list. The operations are now only defined for stacks. It is still possible to access the elements of the stack without using the operations above by pattern matching. Of course, you can pattern match on this. Now you have a list of alpha, and then you can do whatever you can do with lists. Um, oh, geez. Okay, so it's not just a nomenclature thing. There is also ABS type. Encapsulate the definition of the stack type in its operations in a parameterized abstract data type. Interesting.
It's a
So
BS type.
the stack type is an abstract data type, also now here coined ADT. The concrete representation of a stack is hidden, and no object of the stack type can only be manipulated via the functions that define in its ADT declaration. Okay, so this is better ADTs then, because if you make an ADT in Haskell, uh, at
An
least
ADT in Haskell actually means something else. It's
exactly,
an algebraic data type, not to be confused with an abstract data type.
exactly. So this is the main difference then, at least for now, that an ADT actually defines an API. But I thought a module would do that. That's surprising. Anyway, uh, so an ADT here it defines. Okay, so I guess let's actually copy. Oh, I can't copy. Okay, so do we have programs? What about? Yep. Can we run this? Okay. So can we run this? Oops. Yes, we can. Well, we compiled it. So this is a thing. This is definitely a thing. What are your thoughts on it, Marinho?
Uh, I want to read more actually.
So an object of the stack type can only be manipulated. The stack constructor is invisible. So this is also doing not allowing outsiders to do the pattern matching themselves, I guess. Is that am I understanding
Uh,
things correctly here?
I
It is
think
now
you are.
impossible to access the representation of a stack outside. Okay, So this is doing two things. This is forbidding you from using everything that is not defined in an ADT, and this is also not allowing you to have um, fine. I don't want to use the word finer, but total control of the type, because now you cannot pattern match to you want and do the stack to extract the value of it. It's impossible. But it is still parameterized. Wow, this is so cool. This is so cool. I wonder what modules will necessarily fix now. Oh, okay, so you cannot even, yeah, the constructor is not allowed for anything. You cannot even do this. Um, you need to use this empty stack, because to do an empty stack you need access to a constructor, and you can't, and you totally can't. This is awesome. I like this. At first glance, I think this is very cool. It is impossible to see the contents of the stack without popping its elements. So let us add a visualization function. Yeah. Uh, okay, that's very interesting. Very, very interesting. Yeah. Oh, there's a version 3. There's a version 3, friend. So, what is this? uh, is this a name? Is this a constructor?
It's an operator apparently.
But this is after a pipe after this. I don't think it is an operator.
No, it is. It says infix right afterwards.
Oh yeah, there is an infix immediately afterwards. I didn't see that. Uh, wow, but that's so weird. That is so freaking weird. But how does that work? What does this mean? Is this a value constructor that is infixed? Is that it?
Yeah.
Okay,
Yes,
so it is a
apparently.
value constructor. And then you can represent the stack like this. And then you can do the same ABS type and stuff like that. Another example with FIFO. Okay, so this is actually the naive version apparently, I think. Oh, this is just some another notation. So this is the notation of the course. This is probably a more mathematical notation. And this is where we're gonna make the ADT. This is so interesting. So ML provides a way for you to do, because in Haskell we would have to do a bunch more stuff in multiple places, you know? For instance, to not allow the user to have access to the constructor, it is just a matter of not exporting the constructor, right? But this is done
Right.
automatically here. When you define the ABS type, many things are happening. You are already forbidding the use of the constructor. You are already exporting only the functions that it can interact with that type. In Haskell, you would have to define the algebraic data type there, and then in the export only the ones that you are allowing other users to use. Um, but that is in a different module, right? In a module in Haskell, so just in a different namespace. What if you want to use, if you want to forbid in the same file the use of other functions? In Haskell, I don't think you can. You would be obligated to move to a different file. In here, this is already self-contained within itself. So if you want to use a stack, you can only do these. So very nice. I like it. I like it. You can dislike it, Marim. You are free. Uh, Marim, are you there?
Yeah, this actually reminds me a little bit of the mechanisms for scoping in kernel, like John Schutz's Lisp dialect.
Oh. Interesting.
Scoping and encapsulated types. Uh, but that's done in a more dynamic way. This is obviously different.
Well, do you remember the meaning of local? I already forgot.
I'm not sure actually.
Have we seen this before? I don't think we've seen this before though.
Maybe this is a way to say, okay, here's a definition, but it's only used here
In
inside. It's not
within
meant to
this.
be, yeah.
Ah,
That's my guess, anyways.
that makes a lot of
Like
sense.
it's not meant to be exported from this abstract type.
Yeah, unfortunately the guy is not saying in the bullet points here. Oh, that it is normalization and representation. The normalize is here. Oh, the representation is probably it means a constructor. Okay, so yeah, so that's what the logo is for. Okay, so then we're gonna do the binary tree, blah blah blah, walk operations. Yep, height of the tree, binary search trees. Uh, the older notation. This is how you would do it. This is the operations that you need. You're probably gonna put that in the ABS type. Yeah, very cool. Very cool. This I like it.
No modules though.
No, no modules, but there is a thing for modules. Um, okay, so notes. What do we have on
That's for
notes?
higher order functions though.
Oh, the notes is the thing that we were reading before. Mhm. Yeah, I just want to like be very fast on this section just to see if we are missing something, like maybe some notation or whatever. Now some can be defined. Yep, you can make a function in fixed. Um, high order functions on lists. Nothing too crazy. Yep, yep. Folding over integers, functional tables, lazy evaluation. How do you do the lazy? What is this? What the heck is this? It is meaningful to write a function that creates a list of all integers and other prime numbers. A second function might call that. That is similar to the ordinary if expressions. However, it would always evaluate both the then branch and else branch, and it would be useless as a replacement for the ordinary if. Okay, so this if is kind of special, it seems. Oh, okay,
No,
so
it's
this is a
just a
proposal.
function.
No, but this is a proposal, it seems, because simulating lazy evaluation for later. Harper.sml. Okay, that is thing. Okay. Okay, so you think this is a thing? You think this? Is this a thing? Doesn't seem to be. It's not being highlighted here.
It's a normal function.
Oh yeah, that's actually true. Oh then, okay, so then you don't have a built-in way. I thought this would be some sort of a special thing. That's why I didn't catch the drift. Okay, but you can simulate the lazy evaluation, and there are examples in the Harper.sml. That's fine. Okay, we're gonna jump to lambda calculus. I think we both know that, but modules. Uh, so there is a thing called for projector. Oh, that's fancy. You see what the heck is happening here? What is this?
Slides.
Yeah, but what is this interface? Okay. A common software principle is to hide representation. So safety, preventing data objects, changing the design. Yeah, so I thought the ABS type would be just fine. But apparently modules are going to propose something different. So structures. Structures provide a grouping and naming mechanism. A grouping and a naming. Okay, do we have more notes on this? And there's also this. So we can delete this one as well. Okay, so I think this is going to be exactly the same as the slides. So let's keep the slides, they are prettier. Oh, this requires a password. Cool. uh, no, so this is just a prelude. Fine. Okay, we can take a look on that later. Okay, so let's go. So, do you understand? Because it's saying here, structures provide a grouping and naming mechanism. But I still don't understand why would you use this instead of like an ABS type. What is the benefit of this?
Uh, Namespacing probably.
Namespacing. Okay. Very, very interesting. Very, very interesting. So let's go next. So this is just examples. Notice the polymorphic type of for the empty set and the fact that that integer list gets constructed. Sure, but what would necessarily not allow you? Where is it? Where is the PDF? What necessarily would not allow you to do that the same thing for with an ABS type?
You could probably put an abstract type inside of a structure, I would think.
Mm. We can open a structure and then you're gonna receive all of that. Cool. Wait a moment. Okay, so this is a little bit simpler than I thought because you see that these not necessarily need to be related to each other, right? You could have like linear algebra structure and have many things in here. And in here, the ABS type is kind of focused in one thing only. You probably can do like shit with this and have many different things here, but I think having this for specifically for grouping, it's kind of okay now. Do you agree with that?
Yeah.
Okay. So this is an example. Okay, stacks. A stack is a data structure where the last thing we add, blah, it has this operation. So are we going to make oh, signature. Oh, so this is how you do the closed source stuff, right? So your server does this thing, and then somebody pays me, and then I give them the signature, right?
Yeah.
And then they can use my thing, like probably communicating with some type of server, and then but they don't know how I do it. They just know that this is the what they need, right? This is the API.
Yeah.
Okay. Uh, okay, so you can combine them. So you have a module is a signature plus a structure via transparent signature matching. Holy mother flip. Okay, so what is this? So we have a structure which has a column something something, which didn't happen before. Yeah, before we only had has this. The ABS stack comes from the signature, and the structure is the structure. So kind of weird that you not use like module stuff. You see, they are reutilizing pieces of syntax, right?
Yeah.
Uh, okay, so let's take a look on this. So this is defining exception, a data type. Oh, so this is literally grouping both with the signatures and the implementation, and that's it.
Oh, it is.
Okay, that's less awesome than I was expecting. I was expecting magic, you know, magic. Uh, okay, can we now answer the question why a module would solve the Racket Tower problem? Uh,
Because you can depend on the abstract type and not care about the specific implementation.
yes, that is why this solves it. Because in our case, this would be a serializable, right? So this would be serializable. No, I don't want that. Yeah. So this would be a serializable thing because remember the problem. The problem is that we want to write common functionality to people that is serializable, right? That's what we want to achieve. Agree on that?
Yeah.
So in here we would make, I don't know, hashable column serializable, and then we would provide serialize and deserialize, right? And we would assume that stuff from the serializable signature. Is that correct? What I'm saying here?
Uh, I don't think you would do that specifically because when you say structure, you're kind of creating an implementation of the abstraction.
Yeah, but then that doesn't solve our problem yet then, because we need to depend on another implementation. So, but then that's maybe that's gonna come later on. It's 19 slides. Because what we want to achieve is I want to reutilize previous functionality and I want to have some assumptions. I don't want to guess that whatever is calling me is providing me serializable. No, 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 no. I want to have a constraint on that. That was the main reason. And we solved that in the new Racket Tower using generic interfaces, right?
Yeah.
And previously we were using inherent to solve it. Magetta said that a module is the solution in an ML world for this problem. Rust solves it with traits. Haskell solves it with a type class. So maybe you're gonna see later on that this is the actual solution. So we have an usage here. What the heck is the question marks? There can be help functions within a module that are not mentioned in the signature. They compose identifiers that are not bound to anything. What? Functions within a module that are not mentioned in the signature. Their composite identifiers are then not bound to anything. Do you understand that?
You can, I think it means that you can have a helper function inside of a structure, but if that helper is not mentioned in the signature, then you can't use it from outside of the module,
That's so if
the
what you
structure.
said is correct, saying bound to anything is kind of weird. Kind of
Oh
weird.
yes, the name stack dot whatever, some helper wouldn't be bound outside of the context of, you know, the stack definition.
Yeah, no, yeah, but I wouldn't. What you said before, I would say something different to explain that. Do you understand the question mark and the curly braces? Is that does that mean that it comes from a module? What is this? What is the meaning of this piece of syntax?
I'm not sure actually.
Weird. Very weird. But minor details. Minor details. However, we can still get access to the internals. To hide the details, we make the declaration via opaque signature matching. The rest being the same as before. Wait. What is the difference between this one and the previous one? What is the difference between this and the other one? Oh, the symbol. Okay, I see. Um, so to make them opaque, you just add a greater than. and then it's not gonna tell you. Okay, so this piece of syntax must mean that it is a sign that you are checking out the details. It needs to be something like that, related to that at least. Agree?
Maybe.
Because now it is like redacting it, which is which is cool. Very cool. So this is another implementation using lists instead of whatever we were doing before. Oh yeah, we were doing something completely different before. This is just REPL stuff. Okay, so with that in mind, we jump to the functors, whatever they mean in ML. So build structures from structures. Structures from structures. To make a structure, we do as follows. This builds a new structure with the argument structure. This works provided the types and signatures match up.
Yeah, this is like Zig, where you can have a function that takes a type and returns a type.
I think it's miles better than that because this is a compositive of this is a group. It can have many things within it. Functions, types, ABS types, the type aliases, it doesn't really matter. But you
That's
are
also true in Zig.
okay, but you said something different then. You said that you can make a type that receives a type, right?
No, it's a function that takes a type as an argument and returns
Yes,
another type as a result.
yes. This is better than that, according to that sentence here that you said.
No, this is literally the same thing, except the type system, like when you take a type as a parameter in Zig, it just has type. Here you can have more specific types than just that.
Oh, but then you're calling the signature the module's types.
Yeah,
Okay, but in terms of functionality, so a type in Z can do grouping of multiple different whatever.
yes, you can just have a struct and it can have internal definitions.
No. But internal definitions like such as the module thing here. So we're talking type alias, ABS types, types,
Yeah,
well, ADT types,
yes,
values. I think
yes,
constants,
yeah. Functions as well.
functions. Yeah, and then this is a structure that takes a structure. So in Zig you can have a function that takes a type and returns a type.
Yes, a functor is basically a function that takes a structure and returns another structure. But you can in Zig in the type signature you just have to say that value has type. Here you can say that the type is a particular signature, so you can be a bit more specific.
No, but this sounds safer than what you said if the in with the Zig stuff.
Well, in Zig you can actually do all the checks that you need to have the same level of safety, but you have to do them by hand, so it's a lot worse in terms of usability.
Oh, but then you're gonna have to do some like if then else's or switch cases with the type value.
Yeah, you would have to do some compile time reflection on the type.
Ah. Okay, so it's more work, but it seems to me then that it's functionally the same. Is that
Yeah,
correct?
I'm guessing that in terms of ergonomics, this is way better.
Yeah. Consider a
But
simple
then
function.
again,
Go.
but then again, this is a much higher level language, right?
No, but I'm impressed.
It,
Even if you have less ergonomics, the fact that you can do this type of shiz with bits down there, that's impressive. That's very impressive. Um, okay, but
functor
now the
name, argument
answer.
structure.
Now to answer the
Yeah.
question, we still haven't answered the problem, right?
Well,
Uh,
we did because now, if you want, if you want your hashable to depend on something that
oh
is
yeah, we use a
serializable,
functor then.
use a functor. Yes.
Ah, okay. So a functor is the solution to that problem. Okay, okay. And it is like it is 100%. like origin-wise, probably different than the functor in Haskell. But you see that they have some similarities in there in terms of like you're grabbing something of one type, keeping the outer structure the same, and changing the insides. That's how I describe functor in Haskell. This thing seems to be kind of like that because you have a structure and you can and it depends on something else. You see, internally, internally. So
Yeah.
it seems to me I can see some like I'm not gonna rationalize that they same and say that they're the same because they are not, but I can see a relation there, which is cool. So consider a simple function smaller that removes all elements smaller than a given value. Very straightforward, very inefficient, but very straightforward. Um,
How is it inefficient?
well, because it's using recursion. I'm pretty sure that probably there's a theorem out there that if you get rid of the recursion and use it in a loop of an iterate, it's going to be faster.
How would you do that?
In this language, I have no idea.
You don't. Like the only way you can do that if you is okay, you would have to do a tail recursive algorithm. You would have to build the list backwards and then reverse it at the end.
Well, um, anyway, I understand that this is I think the best you could do in a language like this, in a functional language. But
No, this is
if
just the best period if you don't have mutation. Because here's the thing, this is a linked list. Okay?
I think that's a very bold statement. I think the assembly that's going to be generated by GCC in a for loop is going to be better than using recursion. Always.
But in a for loop, you are presuming that, first of all, this is a linked list. You would have to allocate the nodes. Secondly, you are assuming that you would be able to allocate the nodes left to right, which is not the case in an immutable language. Or rather, if you're using an immutable linked list.
You are right about that. Yes.
So you have two options. Either you take the hit on the space and just recurse without being a tail call, which is what they do here, or you take the hit on time and you build your list backwards and then you reverse it at the end.
Also yes, yeah. But when I said what I said, I was more thinking like if you're doing C, I think all competitive programmers they all say to not do recursion. That's my
That's because
memory.
C has a terrible implementation of recursion.
Okay, that's fair. We rewrite it as a
Well,
structure.
not
So,
just recursion, but function calls in general, I guess.
sure, sure. Uh, that's freaking cool. Okay, so then we are grabbing that function which is just a simple function, and we are putting that in a structure, and we call that remove, which is fine. Is limited to integer lists. Why is this function limited to integer lists? Uh,
Because of the rule that if you have an
oh,
operator
oh yeah.
that's overloaded and you can't figure out the
It's gonna
type, you
assume
assume it's
yes.
an integer.
Yeah, okay, I forgot about that detail. I was just saying there is no type signature in here. It's gonna assume whatever, but it doesn't. It doesn't assume whatever. Functors build new structures out of old structures. So we make a signature that allow us to compare things. This feels so fucking close to a type class. Holy jeez. Okay. So we make the signature ordered, which is basically a bunch of requirements, right? But not in terms of implementation, but at least in terms of these functions here. So there's a type
Yes, in
T,
terms of the interface.
and you need to have these. Well, I'm describing the interface that you're gonna have to have. Then you say integer ordered. Ah, This is the critique of Harper on the monoids thing. Are you aware of that critique?
I'm not actually.
Okay. Harper criticizes Haskell because in order to make a monoid of the same base thing, which is like integer, because integers they have two monoids. In Haskell, you need
Right,
to create a new
addition and
type.
multiplication.
In order to differentiate between the two, you need to create two different types because there's a limitation of one monoid per type. So
Right.
you need to make a wrapper on top of the integer, which is not a big deal. It's just literally just that what I said, just a wrapper. But now I think I understand better why he criticized that, given that this is what he was used to. Because look, if you want to make like the sum monoid or the product monoid, you would just do two structure integers, right?
Yeah, one would be integer sum and the other would be integer product, and then they both have the same signature, but they have different implementations.
Exactly. So this is why he criticized that. I still think he went a little bit over what was required to that critique, but now I understand at least the motivation for it because this is what he was used to, and this makes a lot more sense in this particular instance of the monoid. An integer has two monoids. We're gonna write that down. We don't need to make a wrapper because the one monoid per type limitation. So I see. So now we make a functor which receives an ordered. But ordered is not a structure. Ordered is a signature. So I feel a little bit confused. Let's go back to the slide of the
The structure,
functors.
the structure is S.
No, but it has the column. What the column is saying is not the type?
Well, yes, but the type of a structure is its signature.
Ah, that makes sense.
At least that's at least that's what the notation is suggesting.
Okay, so the type of a structure is signature. I see. To build a new structure, we instantiate a functor. This is so cool. You see what we did there? So let's go step by step. We have a function that we want to make it generic. Although it's kind of weird to me because this seems like a solution to the problem that they created themselves. They created a problem in which they said that if it's not types, it doesn't have if it doesn't have a type signature, they're gonna assume it is an integer. So this particular example seems a little bit off because this is a problem that they created themselves. But yes, I 100% understand that this could be created even if this was not a thing. Even if the type inference would just do the thing that it's supposed to do, which is try to make it generic as possible. So then you put the function in a structure called remove. Then you make the type of this structure, which is kind of weird because these functions, this API doesn't appear here. It doesn't appear at all. So they seem a little bit disconnected. But then, and then you define another structure. Oh no, wait. This is the relation. So this is just a random structure, which is in our particular case. This is a more generic approach. So you have a signature, and then you instantiate the structure with that signature as its quote unquote type, and you provide the implementation. So this is basically implementing this API. And then when
Or
you go,
integers.
sorry, or theirs,
Yeah, you
and
implement the API for integers, which is the example that they give.
then you go and create a functor, which is just saying that this is a generic remove, uh, and I'm going to receive something of signature ordered, and that's it. And then if you want to make that for integers, this is how you do it. This is how you do it. Yeah, so the functor is definitely the answer to our problems in the Racket Tower. It would definitely be this. Precisely this. So hashable here, serializable here, right?
Yeah.
And then we have an example which works. Why use functors and structures? Functors are a powerful way to organize software. It's a type-safe way we can we can put constraints on smaller components. Abstract data type allows only one implementation. Okay, so you cannot even put random crap in there. I said that potentially you would be able, but apparently you're not. Cannot be generated by functors. In this course, we will build many data structures with functors. That's it. I really liked this material though. I don't know about you, but this was fun. I would have a ton of fun
Yeah, that's
having these lessons.
yeah, that's very helpful.
Okay, I'm gonna finish the recording now.